Okay, so we've talked about Caesar shift encryption, and we've talked about the shift mixed chains encryption, right? So these are two different encryption algorithms that we've looked at. What I want to talk about next is not another encryption algorithm, actually, but just a different way to use the encryption algorithms we already know. And this different way of using these encryption methods is called counter mode encryption. And so the best way for us to actually talk about this is for me just to do it for you. And it would be great if you'd follow along, sort of demo style here. So without further ado, you see we have actually our fancy shift mix chains where we have 3 shifts, and we also have our simple Caesar shift encryption here. So to start off with, let's suppose that the plain text that we want to encrypt is meme, M-E-M-E, all right? Now, obviously, if we are going to be using this shift mix chains, we have 1, 2, 3 letters in our key. So we should also have key, and our key is going to be CRK for this example. All right, so I need to set my key in my shift mix chains to CR and K. All right, and then I'm ready to go. So the thing is, with counter mode encryption, I'm not going to simply take the plain text characters and encrypt them with my fancy shift mix chains. All right, so the idea is I'm actually going to get away from that, and in getting away from that, you'll see that we come up with a way of defeating frequency analysis attacks. So I still need to figure out, though, how am I going to get from my plain text to my ciphertext? All right, and that's what we'll look at. So the sort of big idea behind counter mode encryption is that I'm going to use my simple mode of encryption, right? So here it's going to be my simple Caesar shift encryption. I'm going to use that to encrypt the individual letters of the plain text, but I'm going to keep changing the key as I do it. And that's what's going to allow me to defeat frequency analysis attack. So what I need is I need a sequence of new keys, an unpredictable sequence of new keys to use as I go through the plain text and encrypt with Caesar shift encryption. All right. And so really this fancy shift mix chains encryption is just going to be there to provide me with that unpredictable sequence of keys. All right. So the sort of secret that makes this work is we're going to keep a counter to tell us where we are in the plain text as we encrypt. Except instead of counting the letters of the plain text as 1, 2, 3, 4, we're going to count them using letters of the alphabet. So we're going to count them using A, B, C, D. And of course, the longer the message, we could just continue on with the alphabet this way. All right. And what we need to do is we need to produce what's called a key stream. So that means a sequence of key characters to go along with each plain text character. And we come up with our key stream characters by encrypting each counter value with our fancy shift mix chains. All right, so let's see this in action on the first plain text letter, which is M. Okay, the counter is A, so I'm going to encrypt A with my fancy shift mix chains, and out the other end, I get I. So I becomes the first key in my key stream. So now I'm actually ready to produce ciphertext characters. So I'm going to encrypt M using regular Caesar shift encryption, but my key is going to be I. So I have to set the key, my Caesar shift to I, and then I can encrypt the plain text M, and I get U as a result. So my first ciphertext character is U. All right, so now we're ready to move on. To encrypt the next plain text character, we need the next character in the key stream. So we have to encrypt B with our fancy shift mix chains. So now we're going to encrypt the letter B, and it's going to come out the other end as A. So our next character key stream is A. So I need to set the shift in my Caesar shift encryption to an A, and then my plain text character is an E. And so the ciphertext I get out the other end is an E. Okay, this is not surprising because if your shift is A, you actually just don't change the plain text character at all. But nonetheless, that gives me, in the context of my ciphertext for meme, that gives me an E for the second letter of ciphertext. All right. Okay, so now we need to encrypt the counter C to get our next key. So we encrypt C, out the other end we get an L. So our next key stream letter is an L. I set the key in my Caesar shift encryption to an L, I encrypt the letter M. All right, and the ciphertext I get is an X. So now I'm ready to encrypt the last character of plain text. That's this final E here, right? And I do it the same way I've done the rest of them. So I take the counter value, which is now a D, encrypt with my fancy shift mix chains. I get an S out the other end. And so S will be my next character in the key string. So I set the shift in my Caesar shift encryption to an S. And then the plain text letter should be E. And out the other end, I get the ciphertext letter W. So my overall ciphertext for the plain text meme is UEXW. And actually already here, we should be able to see why it is that this counter mode encryption is going to cause trouble for frequency analysis, right? Because there were two M's in the plain text, but there are no duplicate letters in the ciphertext. There are two E's also in the plain text, and once again, no duplicate letters in the ciphertext. So the frequencies of the letters in the plain text is not mirrored by the frequencies of letters in the ciphertext. And this means that frequency analysis isn't going to work. All right, so the next step in this actually would be for you to act as Bob and not Alice. That means that you would be receiving a piece of ciphertext and you'd have a key and you'd have to decrypt to get the associated plain text. So I'm going to leave that as a challenge for you.